NVIDIA. We may be joined a little bit later by Ram as well, and he is here to show us deep learning on WSL and maybe something new. Let's see.
Yeah.
Thanks, Rafael.
Hello, thanks everyone for joining. So today we are going to have a little bit of a discussion on deep learning with CUDA on WSL2. As you know, in June, in the Insider Preview, WSL Insider Preview, you have now access to GPU acceleration. That was an exciting feature we worked on with Microsoft, and today is only available for Insider Preview despite the backport of WSL2. Just want to preface it with that. I know a lot of people are excited about it, but it's right now strictly limited to Insider Preview. And today we are going to discuss about not just CUDA on WSL, but more especially how you can do deep learning, machine learning, how you can maybe run mixed workload, like ray tracing workload at the same time as machine learning workload, how you can do all of that within WSL. We are, of course, going to speak about container. We are going to show you how to get started, like how easy it is today to do that. Hopefully, it will be even easier when we'll move to production. And at the very end of that session, we are going to give you a small a sneak peek of what's going to be for the future. We have a little bit of a preview of some of the features that are coming up in the upcoming months. So we are quite excited to show you that for the first time. I know these have been features that you've been impatient to get your hands on. I think Ram might have tried to join us now. Yes? Maybe. Okay.
Rafael, can you hear me?
Yes, I can hear you. I don't know if everybody can right now.
You're in. Welcome, Ram. Thank you.
Perfect.
Yeah, sorry about that. The laptop decided to act at the last minute. So
Sure.
We're going to try me speaking over the phone with Rafael helping me with the slides. Okay, sounds good. All right. So Rafael, yeah, let me quickly introduce myself here. So I'm Ram Cherukuri. I'm a senior product manager for CUDA at NVIDIA. And as Rafael was saying, today we are excited to talk to you guys about CUDA support on WSL2. So Rafael, can we start with the first slide?
You want to go to that one? We already gave them a bit of the outline of the session, so I think you can, while you were joining. So you can go straight up on that one, yeah.
Yeah, so so we wanted to start off by giving a quick overview of what CUDA is, especially for folks if they have not used CUDA in the past. CUDA is NVIDIA's computing platform. And it's a programming model that enables you to use NVIDIA GPUs for accelerating and using it for general purpose computing. So that's kind of the main idea behind CUDA, if you will. And primarily, it enables developers to speed up and accelerate their compute-intensive applications by harnessing the power of GPUs. Primarily, if you have a large chunk of your workload has a parallel component, so that's where GPUs can really help accelerate your applications. And here, of course, we have listed out a few of the primary sort of use cases or dominant sort of use cases that we see, but it's not limited to this. Of course, AI training and inference is the big trend these days. And then media and entertainment, GPUs are used heavily, gaming, of course, and then also in scientific computing. Let's go to the next slide. I also wanted to shed some light on the ecosystem around CUDA. As you can see, CUDA has a wide ecosystem adoption with more than 600 applications that are accelerated using CUDA on NVIDIA GPUs. And we have a strong developer community. It's 1.75 million strong as of this year, which we're very excited about. And we continue to see this growth year over year with lots of other workloads that are coming onto NVIDIA GPUs, and we try to support these different workloads and accelerate them using CUDA. So before we jump into CUDA on WSL, Rafael, if you go to the next slide, I quickly wanted to point out that our goal with CUDA has always been to support both Linux and Windows platforms. So the different workloads and use cases I was alluding to are supported on both Linux and Windows and have been for quite some time. And the link right there is a good starting point for anyone who's new to CUDA to kind of look at the various use cases and also on how to get started. Specifically, I wanted to quickly touch on using on developing CUDA applications on Windows. This is not something that's new. We have supported this for a long time. As I said previously, we leveraged the Windows display driver model to do so. And I've listed a specific link that shows that talks very specifically about getting started on leveraging CUDA on Windows. So with that, let's get to the meat of the topic today, which is using CUDA on WSL, right? So it's important to highlight that this is definitely great for developers that would like to use or need to use Linux tools and tool chains for their application development, but would like to continue to work on their Windows platforms, right? And that's where WSL shines, and it enables that by providing a containerized environment. As you guys know, you don't have to deal with the hassle of like a dual boot or try to use third-party tools to make that work, which is what I used to do a few years ago when I was working on applications targeting embedded SoCs. And of course, most of the cases I needed to use Linux tool chains on my Windows laptop. So mostly my go-to was either a dual boot or having a virtual machine. But yeah, with WSL2, of course, it's much more convenient. And on that note, I'm going to hand it over to Rafael to kind of walk us through how easy it is to get started with using CUDA on WSL2 and how that works.
Okay, so let me redo the setup so we can share at the same time the demo. Meanwhile, we can see if you can take over the slide deck with a more up-to-date version. And let me share my screen so you guys can see while I'm explaining. Here we go. Perfect. So are you able to see my PowerShell console and the display driver here?
Yes, Rafael.
I'm relying on you, Ram.
Yes.
Okay, perfect. So installing WSL today is something that is supposed to be very easy. And the reason for that is because actually your display driver, your NVIDIA Windows display driver that I'm installing right now, is the one that is containing your CUDA driver for WSL, NVML, PTX JIT compiler, and everything like that. So what you can see right now is by installing this driver, which has WSL support, I'm also installing all these library within my WSL environment. Today, this is something that you have to do with the custom driver that we have posted on nvidia.com. You saw the link on the presentation. And that's something that is for the preview only. For the more final versions of it, all our future drivers are going to have the support for WSL built in. What that means is that this dual environment where you have to have the custom WSL driver preview, that's only during the preview timeframe. When the feature is going to go more widely, more broadly, all our NVIDIA driver are going to have support for WSL built in, basically. So that is really something we are looking forward to make the experience much more simpler for all of you, because at that point, it's really like you just install WSL2, you can run your CUDA application just out of the box. You have no custom driver needed. That just comes everything built in. So I have installed my NVIDIA driver. I'm going to open a WSL2 environment. Here we go. And I am going to just go run a very basic application. Ram, can you confirm that everybody can still see my screen for that thing?
Yes.
Exactly as a yes. So here you can see on my screen, I basically done a very basic device query test, which is written with CUDA. That's allow me to see that, yes, I can detect my GPU, everything is fine, and it is the same GPU as the one I have on my system. No problem there. So the installation process is pretty straightforward. What it does, I'm going to give you a little bit of a peek behind the curtain of how we do things for that matter. Actually, we install libcuda.so here in our WSL libraries here, and that is a WSL driver. I want to insist on that point because a lot of people that try WSL think it's more complex than what it should be, right? Like we have a lot of users that try to install a regular Linux driver on the top of it, or that pulls it through their toolkit. They pull a native Linux driver too. And what that will do is that will shadow the WSL driver that comes just built in with your display driver. So here, it's just the easiest setup possible. Just install your display driver and do nothing. You will get CUDA working. If anything, installing like a native display driver or all this kind of thing will actually cause problem, because then that driver, which is not compatible with the WSL, is going to be picked. To show you a bit how that works, since we are in the peeking behind the curtain kind of thing. So if I do a trace on can I copy here? If I do a trace on that thing, you can see it's pretty funny. You will actually see that, yes, I pick that's libcuda.so, which is in that library. And then it's going to look into my driver store, which is the same as my Windows driver store, to pick the real CUDA driver, which is sitting there. So you always get the CUDA driver that's associated with your display driver. You don't have any mismatching here. Now, that's something that we are working on making it easier. We are actually working on preventing user from installing, well, not preventing them from installing it, but putting more safeguard in place, so more error message in case you have native display driver installed, trying to pick the right CUDA driver, even if you installed the wrong one on your system. So although today it's relatively easy to install, you don't have to do anything else. We really want to make it as easy as possible for you, and we are going to provide more and more safeguard in the future. Now, that aside, before we dive into the machine learning side of the demo, I know a lot of you that are CUDA developer maybe, or that are machine learning developer, you might have had a bad experience on Windows with what we called TDR, right? Timeout detection and recovery. If you run a kernel compute shader for more than 2 seconds, Windows will say, hey, my GPU is right now like completely blocked. I'm going to like just remove that application driver, and here we go again. So you could not have any persistent kernel, long-running kernel. That went away with Silk, which we introduced previously, like 2 years ago now, which allow you to preempt compute workload and send the graphics workload back on track. Well, that's a feature that is in WSL as well, and that's a feature with launch kernel that will stay on the GPU for a very long time. It's enabled on WSL, and it is going to be able to preemption to actually circle demo in particular, I'm going to do something a little bit fun. We are and we're going to run it simultaneously from a Blender rendering. Go. Going to move it to the over screen. Can I move the window to that screen? So I have a graphics demo rendering here. Can I view? Perfect. With a screen capture, it's a bit jittery. Okay, here we go. And at the same time, I am going to launch some rendering with Blender. We are going to go there. So here, I'm going to run Blender Benchmark. It's a relatively intensive benchmark on my PC. As a kernel there, I'm going to run it alongside my graphics demo. And what you're going to see is that my GPU, which are both 3D workloads currently, and CUDA workload being used relatively lightly, you are going to see that, yes, of course, my CUDA workload jumps like super high, but at the same time, the demo is still being rendered in foreground without any problem. And I have my CUDA graphic and my CUDA workload. That demo is using CUDA, by the way, on Windows 2, just context switching between Blender, the graphics demo here. So if you want to have your machine learning long-range kernel in the background, demo in foreground, or to your graphics application, even games, although I would not recommend to game while you're training a model in background, that is definitely something that is possible. We have enabled preemptions between all of these workload, and that's really a feature we are exciting for people that are like desktop users, developers, like laptop users that wants to have this kind of multiple applications, like maybe a graphics applications with some console applications running in the background. They have absolutely no problem with that. That's a workload we have enabled. So that's it for the setup part of the presentation. Let me stop sharing here. And we can switch to the rest of the site, which will focus more on the machine learning aspect of it. Ram, if you want to take over the rest. Ram, I don't think we can hear you.
Sorry, yeah, I was on mute. Can you share back the slides? And let's.
You will need to. Did you look at? Yes. I'm not sure you have your latest version of the slides, Ram.
Quick question from the audience while we get that set up. Joseph asks, so the WSL CUDA workloads can run concurrently with general Windows workloads?
That is correct.
So Rafael, if you don't have the link to it, then I can at least speak to the slides, because I think the crux of it is going to be the demos anyways.
Yeah, yeah, I think the link you send is still the wrong one. Ram, you have the old link for that thing. It's okay. It's fine.
Yeah. Do you want to share that?
Go ahead. Yes. Let me try to grab that slide.
All right. Thank you. Yeah. Once again, sorry about that. Yeah, not a good time to have a laptop crash. So as Rafael was saying, we just saw how easy it was to set up the driver. And we also really wanted to talk about maybe a couple of use cases and workloads that you can accelerate using CUDA on WSL2. And we wanted to, of course, talk about deep learning primarily for two key reasons. One is, of course, all of you are aware of how this megatrend is kind of reshaping every industry and application, be it from autonomous machines, automated driving, to healthcare and retail, you name it, you see an impact of AI in there. And a big part of that is also the acceleration, the compute acceleration that is provided by GPUs. That has really enabled us to scale up and also speed up these deep learning workflows for such compute intensive workloads, all the way from training to deployment on GPU accelerated platforms. So now when it comes to WSL, of course, we have heard from our user base saying, yeah, we want, primarily this is students and folks that are deep learning practitioners getting started on this new area. They definitely want to use their laptops to use NVIDIA software stack on running similar applications. And that's where I want to also touch a little bit upon the other part of the equation here. In addition to just the GPUs themselves, NVIDIA offers a pretty deep stack of deep learning software to enable the optimal performance, be it for training workloads or inference workloads. So you see a whole host of SDKs and CUDA libraries that we have invested quite a bit over the last decade or so to really get the most out of these GPUs. And now, as how this pertains to WSL is you can now leverage all these libraries to run similar workloads on your laptops on with WSL2. And that's kind of the focus of the next demo that, Rafael, if you're ready, we can jump into.
We'll do it fully with demo then. Yeah, let me actually go back to the demo screen. That's a bit of back and forth. And go again. So for that next part of the demo, we are going to go more deeply into the machine learning part of it. At first, I'm not going to dive into container. That's going to be the next part. For now, I'm just going to show you like how to run very basic machine learning workloads. So if you have like, you are used to TensorFlow, you are used to PyTorch, maybe you use them in Conda environment, all of that is supported today. Some people think that you need to be in container to have support for that. That's not the case. We actually do support native integration of all these things. Well, native bare metal WSL1 without having the need to jump into a container. So here on that system, I have installed PyTorch. I have downloaded with pip. I have everything pre-set up. And I have the very first sample that they usually give you from PyTorch tutorial. You can see it here. And I'm just going to run it out of the CPU. So that's a very basic first one. Everything is fine. I'm going to switch to my CUDA device. So that's saving it. And rerunning the same command. Here we go. And I'm going to get exactly the same result. So that's reassuring. Everything is fine there too. You can see the spike that happened there. And I'm running my machine learning workload out of CUDA. So you will have PyTorch on the website that we posted. We actually showed you how to do it with TensorFlow. We do have a couple of containers that you can pull from our container repository that have accelerations for that, as Ram just mentioned. So that's really something that's, we wanted to give you the easiest machine learning experience possible if you are a machine learning developer or data scientist. And that doesn't limit itself to container. That also include like native, all the environments that you can have on your system. Now, that said, we do know that a lot of you actually wants to have container support, wants to have Docker support. So one of the first things we put up there was the ability to have NVIDIA Docker working directly within WSL2. So I'm going to start my Docker service. And I know one of the things that people usually ask is, does it work with Docker Desktop? So for now, no. That's something that we are exploring. So right now, Docker is running within that environment with WSL, and that's what I'm going to use for that demo. And I'm going to run pretty much the exact same thing, but this time within a container. So you can see that I'm running with --GPU alls, which actually instruct NVIDIA container, if you have installed NVIDIA container on your system, NVIDIA Docker on your system, to actually mount and make the GPU visible to your container. I'm using the NGC container for PyTorch here, so from the NVIDIA repository, and I'm running the exact same script this time, but this time within my container. Same thing, my GPU was used, and everything was executed there without any problem. Something that some of you might have noticed is that for now, you might see that the NVIDIA driver was not detected in some of the container while the GPU workload was still being executed. That's because these scripts are a bit old. They're actually assuming some names of the drivers to be present. Obviously, that's only if there is a native Linux driver. So they show that warning message. That's something that we are working on fixing. But you can ignore safely that warning. The GPU is correctly mounted and correctly made visible within your WSL environment. So that's pretty much it for that part. So you can really do like we could do way longer training. That would be very boring to do 1 hour training in a demo. So I'm not going to do that. That's why I picked something that is more of a toy samples. But that's pretty much the idea. Something when it comes to performance, and you might have noticed, some of you that were running a very, very small demo workload, to see that the performance might not have been the best. But then as soon as you switch to larger batch, like maybe a little bit like more real life use cases for machine learning, performance was actually going to be quite okay. And that is due to the latency, the extra latency introduced within WSL when we send the packets to the GPU. And that's something that we have worked on fixing, especially on our latest drivers. So we will continue to improve it and to reduce it. And if you try the latest drivers that we have put out there, the performance gain that you will see in this very, very narrow workload is actually solely gained because of the latency improvements that we have. At that point, the GPU is actually running faster than the time that it takes for us to upload that workload to the GPU, therefore causing this performance issue if you have very, very tiny workload, like to the order of the microsecond. So that's something that we have worked over the summer to optimize, to improve, to minimize the latency. We'll continue doing that. There is still avenues to do it, but we have done a lot of improvement on this workload in the previous drivers. So if you have seen some issues with your latency or your executions, like on very tiny workload where you do launch synchronize, for instance, you are doing like very tiny epoch, a tiny batch, that's something that you might have hit. And in that case, we would invite you to try the latest driver. It's actually something that should have improved and will continue to improve over time. And back to you, Ram.
So talking of preview, did you want to share some of the features that we are looking to support in the upcoming driver releases, Rafael, and maybe talk to that a little bit?
Yeah. Let me actually pull up that particular slide. I have it.
And this goes into kind of the
I have to
roadmap
adjust
of
one.
what we are working to fully support and improve as we go. Now, just as a tidbit, starting with the first release that happened back in June, I think we had posted an updated driver a couple of weeks ago, which kind of illustrates all these improvements, Rafael, that you were just mentioning, right?
Yes, that's correct. So something that we will add over the multiple updates that we will do. We are working on adding NVIDIA encoder decoder library. So for all of you that are working with video libraries, we are going to add that. We are going to add optics support. So ray tracing, if you were planning to use to develop for ray tracing within WSL, that's something we are going to enable. A lot of you were asking about NVML support for NVIDIA SMI. You might have noticed that NVIDIA SMI was not working if you had installed it manually or was not present, or even more higher level library like Nickel, which relies on NVML, were not actually properly working because of the lack of NVML. All of these library, all of these features are things that we are planning to add. And I actually do have some of them working today as prototypes. So of course, they are not available in the driver that's you have right now, but I can give you a little bit of a sneak peek of them working today. So one of them, and that's the first one we actually showcase it, is optics and Blender benchmark working with optics in WSL2. Again, this is very prototypey, so that's definitely not something that will happen in the upcoming driver, like the very, very soon one. But that's something that we definitely want to release and to enable you with this workload. So as you can see, this time I launched my Blender benchmark with optics, no longer CUDA. So this is the first time I do it on that driver, and I clean the cache. So it will go and it will compile the cache. That's going to take a little bit of time, like in the order of a minute or so. And then it's only the first time. The subsequent time, it's actually much faster. And then it will run Blender benchmark, not this time with just CUDA, but with optics. Optics relies on CUDA, but it's also part of the display driver. So we had to do modifications to handle proper loading and everything and map it correctly in WSL. So that's what we are working on right now, and that we hope to enable it in the upcoming months. To let you not only play with maybe ray tracing workload, but also maybe something that is a bit more hybrid, having machine learning intermingled with ray tracing. All of these kind of applications are definitely things that we want to enable in WSL. Basically, we really wanted to make it an environment which is ideal for you to develop in. So all the features that you have in Linux, if you are planning to do ray tracing application in Linux, you are planning to develop them, we want to enable you to develop them in WSL and to prototype them there. So as soon as the compilations of this shader is finished, you will see that's my GPU. Here we go. It's going to start executing the benchmark. This is BMW, very classic Blender benchmark running on here. On an RTX card with optics, with obviously the RT cores running there. So you can fully take advantage of that, even in WSL. Another thing that I'm going to show you is the ability to have NVIDIA SMI. So once we will actually add it to classic WSL, you will be able not only to have NVML, to use NVML everywhere, but you will be able to run NVIDIA SMI to verify that your setup is correct, to have everything that you used to do with NVIDIA SMI for your cluster management or for your GPU interface management. You will be able to find it yet again in WSL without having to do anything else to set it up. Today, it doesn't work. We know it was a highly requested feature, especially to troubleshoot your system. That's something we are adding in the upcoming releases. I don't know exactly when, probably in the upcoming month. And that's definitely one of the things that we are focusing on. So more and more libraries being ported to WSL, more and more utilities, The goal is really to make it a development environment where you can prototype anything that you would have done on a regular Linux machines. You could prototype it there and deploy it anywhere else. That's really our goal, and that's why we are working on porting all these libraries, on optimizing the one that's run on WSL today, to really give the best experience that we can there. And that's it. And I think we're right on time.
Yes. Yeah, thanks, Rafael. So definitely my favorite is being able to run our deep learning container-based as well as native stacks on WSL. But I'm sure that you're very excited about the optic support that you're currently working on. With that, yeah, I think that wraps up the session. We have a slide towards the end that gives you a list of resources that you can use to get started. We have tried to document the way to install the driver, as well as maybe to quickly play with a couple of these demos that we've showcased today. Those will be made available to you, of course, after the event. With that, yeah, thank you for having us at this session, and we apologize for some of the technical difficulties, but we do have some time for Q&A.
Great. Thank you so much, Rafael and Ram. Some of the questions were about concurrency with Windows workloads. I think Rafael answered the question. People want to know when are these new drivers with these new features going to land? And
so what I demoed today, what happened with concurrency, and I can actually an explanation of what we do is, let's assume that your GPU is overbooked. Application using your GPU on WSL and 100% application using your GPU on Windows. What we will do, because compute application usually lets the kernel runs on the GPU for a very long time, they don't give back controls to the driver. What we'll do is we have a mechanism, and you can read more on some of our dev blog, which is called CILP. It's compute instruction level preemptions, which means that if it runs for too long, we will actually preempt the current compute shader. We will move to another processes, another actually kernel if it needs to, and that may very well be a Windows one or a WSL one, and start scheduling that one. So we will actually shuffle between these two without any problem. That should be seamless for you. Obviously, we cannot create more GPU space on the go, so it will be 50-50, but you will be able to use this feature already today. That's in the current driver.
Great. Now, do you have any plans for when all of these features will start landing in the, I want to say the upstream, but the standard drivers that you would get through Windows Update?
That will likely come to Windows Update in the whip, or to Windows Update like regular Windows. Regular Windows, it will likely be aligned with whatever GPU support will actually land in regular Windows outside of the whip. I don't know that information, but that will something that will likely be aligned. When it comes to update within the whip, so you don't have to download the custom driver, you can whip driver. We tend to have them relatively coupled. It takes a couple of weeks of delays between the time we post a preview driver and the time it's picked up for whip users, so Windows Insider preview users. We try to be as good as we can there. We know that there is a delay between the two. We don't leave whip user Windows Update one completely out of the picture. We know there have been delays in the past. We're really trying to work hard on that one. When it comes to official release of WSL2 GPUs, that is tied to when Microsoft will release WSL2 GPU support preview. Will happen. We will start caging WSL regular driver. So don't worry, there will not be a gap at a time where we will not have any drivers enabling the support in regular Windows. So we will line up with that. When that happens, we'll line up our driver release there.
That's great. That's great. And the attendees can ask Craig later from the WSL team about GPU compute.
Yeah.
So,
exactly. That's really the right person to ask for that information.
Yep. Well, thank you so much. This has been fantastic. We really appreciate it. Really exciting ray tracing, optics engine, these new concurrency things. People are really excited, really engaged. Thank you so much. And if that's it for questions, we appreciate it. Thank you.
Absolutely.
Thanks for having us.
Evan. Thanks, everyone.
Thanks. All right, streamers, stream watchers, sit tight. And Sohini and I will be back with you in just